last thing that you guys are going to learn are double angle and half angle formulas. So you'll definitely have some questions like this on your test, I'm sure. So the double angle identities, I never, I always say, like, I don't have enough room in my head to remember all these formulas. So I just use the ones that I know already. So the double angle formulas that we're going to do today come from the sum and difference formulas. Do you feel like you have a pretty good handle on the sum and difference formulas? Yeah. So if you have sine of 2x, what we're thinking of is sine of x plus x. And so we know that with the sum and difference formulas, we have like sine of x plus y is going to be sine x cosine y plus cosine x sine y, right? So that's the kind of stuff we're doing here. So we're going to break it apart and we're going to say, well, we have sine of x, cosine of x, right? And then plus cosine of x, sine of x. So if I combine those terms and write it in the simplest way possible, it's going to be 2 of those sine x, cosine x, right? Do you guys see that? So anytime you have a double angle, so for instance, if I gave like sine of 100, it's the same as 2 sine of 50 times cosine of 50, okay? So we can go from double an angle to the single angle in that way. Does that kind of make sense? So if I have cosine of 2x, again, we're going to think of it as cosine of x plus x, like that. And we're going to use the sum and difference formulas for cosine. So as you guys can see on the board, cosine of x plus y is cosine x, cosine y, minus sine x, sine y. Same idea. So we're going to say cosine of x, cosine of x, minus sine of x, sine of x. So the simplest way to write this is cosine squared x minus sine squared x. Okay, almost like that Pythagorean identity, but there's a minus in between. Okay, and that's the one that I memorize, that I just know. So every time I see cosine of 2x, I'm like, oh, that's going to be the cosine squared x minus sine squared x, because I know in my head that it's cosine x minus sine x, sine x. Okay, but there are actually 2 different forms of that, and we're going to talk about those in a second. And then the tangent of 2x, again, so if you remember the tangent formula for a sum, it ends up being tangent of x plus tangent of x over 1 minus tangent of x times tangent of x. So this formula looks like 2 tangent of x over 1 minus tangent squared x. So it's just using things that we already know with those sum and difference formulas. Sometimes we call them the addition and subtraction identities. So that's what goes in this box. So the sine of 2x is 2 sine of x cosine of x. The tangent of x was the 2 tangent of x over 1 minus tangent squared. And then the cosine of 2x can be written in 3 different ways. So the first one is the one that I always remember, cosine squared x minus sine squared x. And then the other 2 we can get with the Pythagorean identity. Do you guys know what I mean by Pythagorean identity? It's the most important identity. Sine squared x plus cosine squared x equals 1. Right, you remember that one? Do you guys know why that's called the Pythagorean identity? That this is how we're going to talk about that at all? Yeah?
Is it because it's effectively a squared plus b squared plus c squared, because the x is, sine squared is the y values, cosine squared is the x values, and when you're squaring that.
Yep, so this point is
the radius of the unit circle, which is 1 unit. And that's also a hypotenuse.
Yep. Did you watch my video? Is that how you got that? Yeah.
I think this is Hawkins.
So we have cosine x, sine of x is the x and the y value of a point, right? So this distance is cosine of x, this distance is sine of x, right? So when you do cosine of x squared, right, the x value squared, and the y value squared, and add them together, you do get 1, right? That was the hypotenuse was 1 squared. That's where that comes from, okay? We all know that one, right? All right, so let's say I wanted everything in terms of, I don't know, sine instead of cosine. Couldn't I replace this cosine squared with something? What is cosine squared equal to? It's equal to 1 minus sine squared, right? So I could replace that, and so I could say, well, I have 1 minus sine squared minus another sine squared. So how would I write that? 1 minus 2 sine squared, right? Exactly, that's the second form of it. And then the third form is like, well, what if I wanted to replace the sine squared with cosine squared, right? So something with cosine squared. Well, sine squared is going to be 1 minus cosine squared. So we would have cosine squared x minus parentheses 1 minus cosine squared x. So as we distribute that negative, we're going to have negative 1 plus cosine squared x. So we're going to have cosine squared plus another cosine squared. So we get 2 cosine squared x minus 1. Okay, so there are 3 different forms. And again, like the Pythagorean identities, you know the different forms with the secant squared and the tangent squared. Do you guys always get those confused? I always get those confused. I always derive them from the sine squared plus cosine squared. Do you know what I'm saying? So like I would divide everything through by sine squared in order to see, oh, I have 1 plus cotangent squared x equals cosecant squared. Do you guys do that? And you can get each of those forms by doing that. Have you never talked about that? No? Okay. So if I wanted to get the next form and I divide by cosine squared, right? Everything through by cosine squared. What do I get? So I do sine over cosine. What's sine over cosine? Cotangent, right? Or tangent, I mean. So I get tangent squared plus 1 equals 1 over cosine squared, secant squared. Those are the Pythagorean identities. So there's 3 different forms, 1, 2, and 3. You guys see? So everything comes from everything else. We don't have to memorize every single formula that we're given. Okay. So number 1, so it says find all the solutions of 2 cosine of x plus sine of 2x. Okay, so this is a really weird equation because it's basically got 2 different angles in it. It's like saying sine of 45 and then something else has sine of 90, right? It's like, well, how do we combine these? We can't say it's 2 of the sine of 45 or anything like that. Okay, so it's like we rewrite this sine of 2x. It's like one of them's a double angle of the other, right? So one of them is a 2x and one of them is an x. That's a weird situation to have. So we wanted to get it to be like a single angle, not a double angle. So we rewrite this. We're like, oh, well, that's just 2 sine of x cosine of x, right? So we're going to have 2 cosine of x plus 2 sine of x cosine of x equals 0. And then this kind of stuff you've been doing since first semester. Okay, so this is one that has a GCF. It has a 2 in common, and it has a cosine of x in common. So we pull the 2 and the cosine of x out. And then we have 1 plus sine of x inside equals 0, right? So we pulled out the GCF. Yeah?
Would it be 7 pi over 4?
So we set each one equal to 0. So we get 2 cosine of x equals 0. Then we get sine of x equals negative 1, so close, but negative 1. Yeah, so that first answer, the one on the right, is 3 pi over 2. And then cosine is equal to 0. Well, that would be here and here. So we also have pi over 2 as well. So we have 2 answers. Okay, it's all related to things we've done before, right? We can do this. So this one, it says use a double angle formula to solve this equation. We actually don't need a double angle on this one. You could solve this without one. But if we notice, hey, we have a GCF of 3, and then we have 2 cosine squared x minus 1, you might notice, oh, 2 cosine squared x minus 1, I know what that is, right? It was here, 2 cosine squared x minus 1. So it's equal to cosine of 2x. So you could say, oh, that's going to be cosine of 2x times the 3. So basically you're finding where cosine of 2x is equal to 0. Do you remember doing that first semester? What did we do when we had like a 2x instead of an x?
You go around the answer.
Yeah, and we let like that w equal 2x. So we have cosine of w equals 0. Did you guys do a w substitution? So we're saying, oh, what angle gives us a cosine value of 0? Steven, you with me? So it'd be here and it'd be here. So we'd have w equals pi over 2, 3 pi over 2. But like Christian's saying, if we're trying to get we're trying to get x values that are on 0 to 2 pi, we want w values, right, to go from 0 to 4 pi. We want to go around twice. So then when we replace our w with 2x, we divide by 2. And we're between 0 and 2 pi. Nope, those would be here and here, right? Are you saying when you divide by 2 to get the final answer? Yeah. So let's find the other w's first, though. So we're going to go one more rotation around. So add 2 pi to each of those. So we're going to have 5 pi over 4, or 5 pi over 2, I mean, because we're adding 4 pi over 2. Right, and then if I add 4 pi over 2 to this next one, right, which is 2 pi, what do we get when we add 4 pi over 2? 7 pi over 2. But those were all w, which is 2x. So now we take all of those and we divide everything by 2. So we're going to get x equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And if you do it correctly, you know that you did it correctly. Like I had someone, do my study guide earlier, and they were like, oh, my answers go over 2 pi. And I was like, then you did something wrong, right? Because if your answers go bigger than 2 pi, you haven't divided by 2 or something, right? So in this case, 7 pi over 4, where is that? That's right here, right? That's pi over 4 away from being at 2 pi, so we know that we did that correctly. Okay, so we have all the answers up to 2 pi. All right, so this is where you might want to look at your additional notes. So you guys have some additional notes that I passed out. Okay, I had one typo, and I put in a +2 on the back side. So if you see a +2, that is supposed to be there. All right, so it says write each expression in terms of a single trig function. Simplify if possible. Okay, so if you see 2 times cosine of an angle, or sine of an angle, cosine of an angle, or cosine of an angle, sine of an angle, right? That's set up like that double angle for sine, right? Do you guys recognize that? So we had sine of 2x is equal to 2 sine of x cosine of x, right? Do you guys see how this is set up like that? All right, so what is it all equal to? It's equal to sine of what? Yeah, 2 times 67.5. And 2 times 67.5 is going to be what, 135? It's 135, right? Because 60 plus 60 is 120, and then 7.5 plus 7.5 is 15. So I think it works. Okay, do you know the sine of 135? If you do, go further. But on your homework, if you get something like, I think one of the answers was like sine of 190. We don't know what 190 is, like the sine of 190, so we stop, okay? But if you know sine of 135 and you're like, oh, that's a unit circle value, I got that. That's 45 degrees past 90. That sine value would be root 2 over 2. So go further if you can. Okay. So this next one is 1 minus 2 cosine squared of 105. And if you look back at our formulas, it's a little tricky because it's 1 minus 2 cosine squared. And we have 2 cosine squared x minus 1, right? So it's a little bit weird, right? So we knew that if we had 2 cosine squared x minus 1, that was equal to the double angle for cosine. It would be cosine of that 2x. But this one's weird because it's 1 minus 2 cosine squared. Yeah?
So if it's 1 minus, then you also have minus 1. But that means you just effectively take out the 1 and you have it as sine squared.
Yep. Do you guys see what he's saying? So it's the opposite. It's like on those equations when in algebra, sometimes you would have like x squared minus 4 over 2 minus x, and you'd be like, oh crap, when I factor this, I get x plus 2 and I get x minus 2. But it doesn't look exactly the same as 2 minus x. Do you guys remember those? And so we pulled out a negative 1, and we were like, oh, but it's really, negative x is x minus 2. And then we were able to cancel. So we gain a negative 1. That's what's happening here. We're gaining this negative 1 that we're pulling out to the front. And then it becomes our double angle like we want. So we get negative 1 times, and then we have cosine of double that 105, right? 2 times 105, which is negative 1 times cosine of 210. Do we know cosine of 210? Yeah, it's a little bit past 180, right? So the cosine of 210 is root 3 over 2. Well, negative root 3 over 2, actually. It's negative direction, right? So we get negative 1 times negative root 3 over 2. So our answer is root 3 over 2. So that was a tricky one. It's not in the fourth quadrant. It's actually in the third quadrant, right? It would be over here because it's past 180, a little bit past 180. So here's 180 degrees. 210 would be right here. You get it? All right, how about the next one? Sine squared pi over 12 plus cosine squared pi over 12. Any thoughts? Clark, you know this one. I know you know this one. Sine squared of an angle plus cosine squared of the same angle. Yeah, it's 1. Don't worry about the pi over 12 thing, right? Sine squared plus cosine squared of anything, x, theta, whatever you want to call it, is always equal to 1. This isn't one of the double angle ones. I just tried to trick you. This is all equal to 1. But what about cosine squared minus sine squared? Is that a double angle one? So go back and look.
Oh, yeah.
Yeah, it's the cosine of 2x, remember? Because cosine of x plus x was cosine x minus sine x sine x. So it ends up being cosine of 2 times pi over 12, which is cosine of pi over 6. Yeah, so pi over 6 is over here, right? Which, as Christian's saying, root 3 over 2. Exactly. Make sense? Easy enough? All right, can we do the triangle ones? You guys hated the triangle ones in the last test. My students hated them too. But you guys got this. Good. So we're telling you that it's in quadrant 3. How might I say that on a test? I might say something like, oh, quadrant 3 is between pi and 3 pi over 2. So that's our math language. We might see it in a weird way, right? So this time I'm just saying, oh, it's in quadrant 3. So we have some kind of ray to create that angle, and we connect the x-axis with our 90 degrees. Are you with me?
Yeah.
And we have opposite, and we have hypotenuse. And Michael's asking a good question. He's like, how do you know which one has the plus and minus? Because he's like, I know it's negative 2/3, but sometimes it's negative 2 over positive 3, and sometimes it's positive 2 over negative 3. And that's when you use the quadrant, right? So we're saying, oh, it's the third quadrant, so we're negative for the x and negative for the y. Our hypotenuse, we call that the radius, is always positive. We're only worried about the x's and y's being positive or negative. Okay, so then we find this missing one, and it's not pretty because you know what? Sometimes math isn't pretty. It can't always be 3, 4, 5 right triangles. So we got to find this one, and if you want to call it x, you can. So we have x squared plus negative 2 squared equals 3 squared. So you have 9, and you have 4, and some of you guys will be able to do this in your head. You'll be like, oh, it's going to be plus or minus root 5. Is it the positive one or the negative one? It's negative because it's in the third quadrant, right? Does that make sense? So then we have sine of 2 theta. And this is tricky because this is just theta. This isn't 2 theta. We drew the picture for an angle of theta. So whenever we're using this picture, we need everything to be theta, not 2 theta, right? So we say sine of 2 theta is 2 sine of theta cosine of theta. And we can get that sine of theta and cosine of theta from our picture. Okay, so we go through our picture and we're like, oh, sine of theta is going to be opposite over hypotenuse, right? So it's negative 2/3. And then cosine of theta is going to be adjacent over hypotenuse. So it's negative root 5 over 3. And we start multiplying across the top. If you want to think of that as over 1, you can. So we have 2 times negative 2 times negative root 5. So we get positive 4 root 5 over 9. Exactly, good. Okay, that's a hard problem. You guys understand this, though. It's all building blocks, right? That's why you can't get behind in, like, pre-calc. Once you get behind and you don't know your unit circle, oh, man, the whole rest of pre-calc is a struggle. So you got to know all this stuff. We build, especially the next 2 chapters on vectors and polar coordinates. Yeah, still the same stuff. Yeah, physics and pre-calc are interconnected. When the school first started, all of the juniors were in pre-calc and physics at the same time, and Dr. Vesper had both of them. And he was like, it was the greatest thing ever, because I'd be like, oh, yeah, we just did this in pre-calc. Let's do this now. So they're very interconnected. All right, so let's try this next one. So if we have sine of 2 theta, can we do cosine of 2 theta? Do you guys remember what it is now? Yeah, cosine squared theta minus sine squared theta. Good, Stephen. So we had those values, right? Cosine of theta was adjacent over hypotenuse, so we're going to square it. And sine of theta was opposite over hypotenuse, so we're going to square that as well. So we get 5 over 9 minus 4 over 9. Is that right? So we get 1 over 9 is our answer. So that's cosine of 2 theta. Easy peasy. All right, so let's try these ones. So solving the equations. So don't let them scare you. You got this. We can solve these equations. So sine of 2x minus cosine of x equals 0. Do you notice we have a double angle and a single angle? That's always bad. We want them to be the same type of angles. It's like having a w and an x in a problem. Like, that's just weird. We never have those. Okay, so we're going to change this, sine of 2x. So it's 2 sine of x cosine of x. Right, we change it into its double angle form. When we do that, we see we have a GCF of cosine of x. So we have 2 sine of x minus 1 equals 0. And we set each piece equal to 0. So we have sine of x is equal to 1/2, and we have cosine of x is equal to 0. So cosine is equal to 0 at pi over 2 and 3 pi over 2. How about the sine is equal to 1/2? Close. That would be the root 2 over 2, though. So 1/2, where's the?
Sorry, 1/2 is pi over 6.
Uh-huh.
Pi over 6.
Yeah. I know what you're thinking, because I always used to do this, Christian. I always thought, oh, directly in the middle, this is going to be exactly half. But it's not. It's a little bit higher, isn't it? But it looks like it. You're like, oh, it should directly be halfway between a height of 0 and a height of 1, but it's not. It's kind of weird. So strange. All right, so we get that. All right, this is the one I had to edit, so I put +2s on your paper. All right, this is a complicated formula. So we have cosine of 2x, which we know is cosine squared x minus sine squared x, but there's other forms of that. But let's say we put that down first. And then we have our minus sine of x equals sine of 2x is going to be 2 sine of x cosine of x. But we're dividing by cosine of x. That's kind of nice for us, right? So those cosine of x's go away. Yeah.
How did you get the cosine squared x minus sine squared x?
I'm replacing the cosine of 2x with that. That's all that.
Oh,
You get it? All right, but this should kind of bother you, because if you think back to first semester, we have had problems that have like sine squared in them, right? You guys, I always wrote these ones on the, we've had things that look like this before, right? And we factored, right? This is a factoring problem, but right now it does not look like a factoring problem. What's the issue with this? Yeah, that cosine squared, that should bother you, right? It should all be in terms of sine or all be in terms of cosine. So can we change it? Like that cosine squared is 1 minus sine squared, right? Isn't that 1 minus sine squared? So that means we have 1 minus sine squared x minus sine squared x minus sine of x equals 2 sine of x plus 2. Okay, so I have negative 2 sine squared x. And I have minus sine of x, and I'm going to join it with the negative 2 sine of x. I'm like taking that 2 sine of x and I'm subtracting it over. So I'm going to have minus how many? 3 sine of x, yep. And then I have a 1 on the left-hand side, and I'm going to subtract the 2 over. So I'm going to have minus 1 equals 0. You guys see that? Do all those negatives bother you? They bother me. I hate all those negatives. I don't like factoring with negatives out front. It just bothers me. So we could add them all to the other side, or we could divide everything through by negative 1. So we're going to get 2 sine squared x plus 3 sine of x plus 1 equals 0. And I just said that one, right? We know how to factor something like that. Yeah, like you could do like a w substitution. And you could be like, oh, 2w squared plus 3w plus 1 is 2w plus 1 times w plus 1, right? Or you can leave the signs in. Or you get it, yeah. How did I get the plus 1? This 2 joined this one. So it became negative 1. And then when I divided by the negative, I got a plus 1. Makes sense. So we get to the point where we have sine of x equals, it ends up being a negative 1/2. and sine of x equals a negative 1. So sine is negative 1/2 in those two places, and sine is negative 1 at the very bottom. P sine. So what ones do we get? 7 pi over 6, I agree with that. 11 pi over 6. Now, Christian called that negative pi over 6, which technically would be kind of right? I didn't say, did I say on 0 to 2 pi? I might have. Yeah, I did say it was on 0 to 2 pi. So if it was negative pi over 6, you just add a rotation to it, add 2 pi to it. And then what's the last one? 3 pi over 2. You got it. Those are the 3 answers. All right, can we do some prove the identity ones? We're almost there. Power through. It's so rough. Double 7th period. We should never do double 7th periods. They should just be at the beginning of the day. We should flip the whole schedule. So here we go. So let's start with the, I always say start with the more complicated side. So in this case, I'm going to start with the left-hand side, which is 1 plus cosine of 2x over 2. And I see that on the right-hand side, I don't have a 2x going on. I have an x. So I want to get this to a single angle. So I can replace this cosine of 2x with cosine squared x minus sine squared x, but do you think maybe there's a better choice? So looking back at those, it's been a while. Gotta go back a little bit. There's 3 different possibilities for cosine of 2x, right? So which one do I want?
1 minus 2.
So do we have a sign on the right-hand side? Yeah, it's probably not. So let's replace it with 2 cosine squared x minus 1. Now, if you had done the cosine squared x minus sine squared x, that's fine. That's what I do. Because I hate like thinking about 1 minus or, you know, the 2 cosine squared minus 1. Like I don't like thinking about the which one comes first, the 1 or the cosine or whatever. So if you do that, that's fine. So we get 1 plus 2 cosine squared x minus 1 all over 2, which is 2 cosine squared x over 2, which is cosine squared x. Is that the right-hand side? Yep. So it all equals the right-hand side, so we're good. When you prove things, you know what, if you ever look in math books, they always have a little square. So if you ever want to do a little square, you can. That means done, I proved it. I usually do little check marks. It's like the mic drop. So it's like, done, did it. All right, so this next one, ooh, really looks complicated on that right-hand side, right? So let's start with the right-hand side this time. So we have cosine of theta plus sine of theta multiplied by cosine of theta minus sine of theta.
So cosine 2x.
Yeah, so you guys are thinking maybe we should FOIL that top part out? I agree. So Steven's saying cosine squared x minus sine squared x,
Yes, that's what
or thetas. What about the bottom though?
1.
1. So what's the top?
Cosine 2x.
Yep, is that what we want? Yep, that's the left-hand side, right? So we're good. So we got the right-hand side equals left-hand side, done. All right. So the next thing we're going to do are power reducing formulas and half angle formulas, but I'm going to give you a second to work on your homework. Ooh, we're almost there, aren't we? 10 minutes? That's all we got. It's 10 minutes? That's rough. All right, so let me show you these then. All right, so it says if you solve the double angle formula, so you guys know how we had, whoops, I'm really going to make you dizzy. So we had this. So cosine of 2x equals 1 minus 2 sine squared x. So if we solve for the sine squared part, so everybody look up here. This is a really weird thing that I'm going to do. I'm going to add the 2 sine squared over to the left because I don't want it to be negative. So I'm going to add it over, and then I'm going to do 1 minus cosine of 2x. So I just kind of rearranged. And then I can divide by 2 on both sides. So that 2 is now gone.
Wait, are you doing the sine of x over 2 right now? Or are you just showing me?
I'm showing you how we get this, yeah. So sine squared x ends up equaling 1 minus cosine of 2x over 2. So some people call these the power reducing formulas. You do not need to memorize these. What this leads to is that if instead I don't want x and 2x, but instead I talked about, let's say, u and half u. So this ends up being the u over 2, and this ends up being u. Oops, not 2u though. u. I can get how a half angle is related to a single angle. So you know how we did double angle is related to single angle? Now we're going to do half and single. And what happens is we take the square root of both sides. So we get the sine of half of an angle ends up being plus or minus the square root of 1 minus cosine of u over 2. Okay? So you don't have to write anything there on the notes. This is what leads to these. Do you guys see how the sine of half of an angle, x over 2, is plus or minus the square root of 1 minus cosine of x over 2? Yeah, these are called the half angle identities. These come from the double angle. It's just solving for the other thing, okay? And that plus or minus depends on our quadrant that we're in. So I'll explain that in this example. So if I have tangent of 7 pi over 12, some of you guys have no idea what 7 pi over 12 is, but do you know what 7 pi over 6 is? Yeah, that's here. How many degrees is 7 pi over 6? 210. So how many degrees should be 7 pi over 12? How is that related? It's half of it, right? So 105. Do you guys see that? Because 7 pi over 12 has a denominator that's been multiplied by 2. So it's half of 7 pi over 6. So where's 105? It's in the second quadrant, right? So this 7 pi over 12 is half of 7 pi over 6, which is half of 210. So all of that equals 105 degrees. So 105 degrees is in the second quadrant. So if I'm asking you for the tangent, is tangent positive or negative in the second quadrant? It's negative because the sine is positive and the cosine is negative, right? Is sine positive or negative? It would be positive, right? So you can get all those different signs. So see how each one has like a plus or minus with it? You can decide if it's the positive or negative version by what quadrant it's in. So if I have 7 pi over 12, I can do this half angle identity. Is there another way that you guys have done this on your homework? Besides doing a half angle, have you guys done things that look like 7 pi over 12? You did with the addition and subtraction things, right? You can get this answer with addition and subtraction or half angle identities. It doesn't matter. You can do either way. What the test will probably say is use a sum and difference formula to find this, or use a half angle formula to find this. It will tell you which one to do, okay? So tangent of 7 pi over 12, that's going to be half of that 7 pi over 6. Look how many different forms there are for tangent. Again, don't memorize these. You'll be given them. Do we want to do the one with the square root? No, that looks really hard. I would probably do the 1 minus cosine of 7 pi over 6 over sine of 7 pi over 6. Why am I using 7 pi over 6 now? Because it was tangent of x over 2, right? So our x over 2 is 7 pi over 12. So what's x? It's 7 pi over 6, right? So then I have 1 minus cosine of 7 pi over 6 is negative root 3 over 2. And sine of 7 pi over 6 is negative 1/2. So I get 1 plus root 3 over 2 divided by negative 1/2. The only thing that I don't like, that it's a fraction within a fraction. How do I fix that? Yeah, you could multiply by the reciprocal or multiply by 2 over 2 or even negative 2 over negative 2. See how that negative 2 is on the bottom? Like negative 1/2 is on the bottom. So if we multiply it all by negative 2 over negative 2, it might be a little bit nicer. So we end up getting negative 2 minus root 3 all over 1. That's our answer. Okay. Okay, how about this one? 5 pi over 12. Half of what? Half of that 5 pi over 6. Where's 5 pi over 6? Right here, right? So if that's at 150 degrees, what is 5 pi over 12 then? It would be 75. Am I in the first quadrant, second quadrant? First quadrant, right? So will sine be positive or negative? It's going to be positive. So in the formula, we have plus or minus the square root of 1 minus cosine of 5 pi over 6. That was double, right? Over 2. And we want positive because we're in the first quadrant. So we're like, okay, got this. It's going to be positive square root of 1 minus, what's cosine of 5 pi over 6? It's actually negative root 3 over 2, yep. get it? That's okay. So we end up getting 1 plus root 3 over 2 all over 2. Don't like that it's a fraction within a fraction. So we have 2 plus root 3. And this is all over the square root of 4, right? Because that square root goes over all of it. So what I'll often do, so if you have my key or something and you're checking, I'll have over 2 there. Because I just go ahead and take that square root of 4. Okay, this is very different than when you guys did sum and difference formulas. Did you ever have something that looked like that? No, we had those ones that had like root 2 and root 6, right? Like root 2 plus root 6 all over 4, right? This looks nothing like that. They're the same answers. This is just a nested root form. We don't usually have nested roots. There are ways to unnest a root. I'm not going to teach you how to unnest the root. Just leave it like that. That's fine. You can check on your calculator. They're identical answers. Yeah?
So how did you get a positive number?
Because I knew that in the first quadrant, right? So I went through this whole thing, and I was like, 5 pi over 6 is at 150. So half of that is going to be 75 degrees. And 75 degrees is in the first quadrant, which has a positive sine value.
So like when you get 150, isn't it already half?
You add the positive anyway because you're in the sine. Is that what you're saying? Sometimes if I was at like 250, let's say, well, that's in the third quadrant. Sine would be negative, but half of it is 125. That would have a positive. So you need to think about whether or not sine is positive or negative for our half angle. Yeah.
How can you have a square root under a square root? So
I know, isn't that weird? Doesn't it feel wrong?
yeah.
It feels wrong. Yeah, I wish I remember. There's a trick I looked up one time on how to unnest this, and it just brought so much joy to my life. But I can't remember it right now off the top of my head. I'll have to look it up. Yeah.
Does it matter, like, which tangent formula you use, or did you just, like, choose that?
You can just choose whichever one, yeah. And then the last one, again, is a triangle drawing, right? So it's saying that x is between 3 pi over 2 and 2 pi. So you'd have x here. You'd have opposite and adjacent, right? Negative for 5 and positive for 8. You'd find this missing side, which ends up being, what, 25 plus 64? Ooh, 25 plus 64, so 89 under a square root. Isn't that lovely? And then you'd go through this work. So you'd say, oh, tangent of x over 2, I'm going to use one of these formulas. And then like cosine, so it'd be like 1 minus cosine of x all over sine of x, which is going to be 1 minus cosine is adjacent over hypotenuse, all over sine, which is opposite over hypotenuse. So you would clear those fractions by multiplying by the square root of 89. So it would give you the lovely answer of square root of 89 minus 8 all over negative 5. And that would be it. Gross, huh? All right, so that's the half angle stuff too.